Alright, in winter 2018, we did not get through preparation 6.py in class on the week 3 Wednesday, so let's take a look at it in this video. Alright, so we first begin, we define a class myClass, and it's got a class variable called A. This class variable belongs to the class itself. It doesn't belong to instances of the class. When we say that it doesn't belong to instances of the class, it means that they all share the same one. And it's reflected in the syntax. We can call it by printing out myClass.a. So when we run this first cell, all you really need to know is that the class variable called A has a value of 1 right now. And notice we later redefine what myClass.a, the class variable, is. We're going to say it gets x, and that might be 2, or it might be whatever we enter in as an input into the initializer. Why didn't it change to that? Well, that's because the initializer hasn't run yet. We haven't created any instances of the class, right? So we've just defined these member functions. None of them have actually executed. So really, all that we care about is this statement right here and this statement right there. And so clearly A is going to be 1 at that point. Okay. Now, when we get into this cell, we now create an instance of the class. So this code, this initializer, is going to run. We don't provide any arguments, so the default value is going to apply. X is going to be 2. That's going to say 2 right there, and then myClass.a gets 2 effectively. So the class variable has now changed to 2. And so this here is definitely going to print 2. Now, how about this one, o1.a? Well, there might be one way to look at it is, oh, aren't you asking for the instance variable called a corresponding with the instance of o1, instance referred to by o1? Well, there is no instance variable called a. There is only a class variable called a. And so this is not a preferred syntax. This is not the best way of writing it. I prefer to write myClass.a, but the convention is in Python, we're going to let the user write this out, and because there is no instance variable named a, we'll print out the class variable called a. And so both of these are going to be 2 instead of 1, because running the initializer effectively changed the class variable to 2. Let's run that. Alright. Another thing I wanted to note, look here, this is not something you do in Java. Inside the class, you have to refer to the class variable a, not just by regular old a. That's going to be a syntax error. Local variable a is assigned to but never used. It assumes as a local variable, the local to this function. You have to specify the name of the class and the name of the variable. And instance variables, of course, always self. Alright. Alright, this time we're creating object referred to by o2. We're passing 4 into the initializer. So x is going to be 4 in this case. So myClass.a gets x, so myClass.a is now 4. And let's see, o1.a, o2.a, there is still no instance variable o1.a. That belongs separately to o1 or o2. They're all sharing just the class variable. So all these should print out 4. Okay. Next one, passing in 5 and 6 into the constructor. So x is going to be 5, y is going to be 6. myClass.a is now going to be 5. o1.a, o2.a, o3.a, they're all going to be 5. Right? Because they're o1.a, o2.a, and o3.a really just mean the class variable a that's in the myClass. So I should really be calling them myClass.a. So they're all the same right now. Now we specify myClass.a gets 7. Alright, we're changing the class variable. Again, these are just referring to the class variable a, so all these should print out 7 as well. So will myClass.a, incidentally. Although that's pretty obvious, right? Now let's do something a little bit trickier. What happens when we say o1.a gets 8? Now you might think because o1.a is the class variable, right? Well, it turns out when it's on the left side of the equal sign, we are effectively creating an instance variable o1.a. We're not referring to the thing that we had been calling before o1.a. For whatever reason, Python lets you, well, it makes some sense, right? Python wanted to allow you to, on the fly, outside of a function, create new attributes for a class. That's something that was desired in the language, and so it's letting us do that. It's letting us create an attribute for that object, an instance variable, that has a value of 8, but that's specific to o1. Okay, so we've basically severed the link between when we write o1.a and the class variable. So all of these, o2.a, o3.a, those are still the original class variable from my class. They're the same as my class.a, but because we've written o1.a gets 8, we've basically created a new instance variable in the object o1 and attached 8 to that. So these are going to be 7, and this one is going to print out 8. So 7, 8, 7, 7. Alright, then when we delete that o1.a, well, it turns out there's still an o1.a that's going back to the myClass.a. So all these are going to be 7 as they were before. Now what is o1.b? We forgot about b. We haven't looked at it before. Well, we've got to remember, the first time we ran it, x, so like, how does b get set? B gets set here. It's set to whatever y is. Now, this first call, well, y is going to be 3 because we didn't pass in a value. This second call, y is going to be 3 because we didn't pass in a value. This call, y is going to be 6. We did pass in a value. So in this case, 6 goes into y, y is 6, self.b gets 6. But that's only for o3. o2 and o1 are both going to get the default values of 3. Did I mess up there? Okay, o3 is going to have a value of 6. o2 and o1 are going to have values of 3 because they're the default. So when we run this, I think we're going to get 3, 3, 6. Okay, now print myClass.b. What does that mean? What is myClass.b? There is no class variable called myClass.b. So even though when you say o1.a, it will tell you what the class variable is. It doesn't work the other way around, because that would absolutely make no sense. Because my class is the class as a whole. Which one of these instances would it give you the instance variable of? If you just write myClass.b, well, which do you mean? o1.b, o2.b, or o3.b? It makes sense in the other direction because o1 is an instance of my class, so it makes sense that there's only one thing it could possibly be. o1.a must mean myClass.a. It just doesn't work the other way around. Okay, so this is going to be 3, 3, and then 6. All right. Oh, sorry, that was known before. But myClass.b, excuse me. Oh, I didn't mean to run this cell. I meant to run this one. This is going to be an error. What does it mean? My class has no attribute b. Right? You're not specifying which instance. B is an instance variable. You're not specifying an instance, therefore you cannot get it. Doesn't make any sense. You can get a class variable even when you specify an instance, but you can't get an instance variable when you don't specify an instance. Okay, o1.b gets 9. Well, I guess we see what the output was on here. What's going on? Well, we're manually setting the existing o1.b. It was an attribute already. o1.b already existed. It was 3 from before. We're just setting it to 9. That does not change o2.b or o3.b. Those are independent variables. o2.b is the b that's belonging to o2. It's not a class variable, it's an instance variable. So it's specific to o2. Likewise for o3. So we're only changing the b corresponding with o1. I know I'm saying it in a lot of different ways just because I want you to get used to hearing it in many different ways and maybe be able to explain things in many different ways. I'm using interchangeably sometimes the words instance variable and, well, I think I'm pretty careful about that, but sometimes there's more general words like field or attribute which can mean instance variable. Sometimes it's, at least in Java, they can be used to mean class variable as well. But I'm gonna try to be more careful and use, typically when I say field, I think I'm usually in this class going to be referring to an instance variable. Same thing with attribute. Alright, so that was the end of this trickiness. Now when we get to the private stuff, you don't have to memorize this. We're not going to talk about it too much in the class. O1 under underscore C. Where is that coming from? It's always going to be 10, but it's a private variable. We've defined it inside the class with the double underscore, and that makes it private. That means when we look at from the outside, we're not going to be able to access it. When we try to print this, this is going to fail. Error. Now, in IPython, not the regular Python console, but the IPython console, there's a helpful little feature where you can type the name of the object, dot, and press tab, and you'll see the list of different things that you can do. So there's o1.a, we know about that. There's o1.b, both of those. I guess o1.a, interesting, that's how it refers to my class.a. Right, because o1.a is the same as o2.a. Yeah, okay. But there's o1.b, which is our instance variable from before, but it also tells me there's this getC and setC. Turns out it doesn't specify, but these are functions. I can effectively use these to get the value of the private variable. I can also set it, right, and o1.getC changes. So it's not private in the sense that you can't access it. There's a little bit more control. And I think that you can probably change how these work. I don't know exactly, but that gets into the whole... Look, if you know what private variables are for and how to use them, then you can imagine the use of having getter setters. I won't get into that here because we're not caring too much about private variables. All right, o1.double_c gets 11. Is this going to change the value of my private variable? Let's make sure we set it back. o1.setC is back to 10. Okay, so it's back to here. So we'll make sure that it's 10 as it was before. Okay, when we change this, well, we weren't able to print out o1.double_c, right? So do you think we can set it like this? Well, it's going to do something. What's it going to do? It's going to create an attribute or an instance variable corresponding with o1 that's called double_c. It's not going to be private. Okay, so we can print this, and that's going to print that new attribute, and we can print this, and it's going to print the original private variable. The new one is 11, the old one is 10. 11, 10. Then we delete that new instance variable, and that, well, I guess, yeah, then we can, well, if we do that, then we're not going to be able to see it anymore, right? So if we do that, and then we do o1.double_c, or we try to print it like we did before, that's not going to work, right? There is no more in it. And we can... I mean, I don't think we expect o1.getC to change. It should still be what it was last time. It should still be 10, right? There's no reason for that to have changed. o1.setC 12, o1.getC 12. That's going to be 12 again, okay? And then finally, let's see, a little bit of interesting information. Variables only refer to objects. They don't hold the objects themselves. So o2.b, what is that? o2.b, well, let's see what it was from before. I don't know, do we ever change it? o1.b got changed, but o2.b I think is what it was when we first created o2. We passed in this 4, it went into x, but y was 3, so I think o2.b is still going to be 3. o2.b, okay, good. But then when we say o2 gets o1, that means o2, the reference, is now referring to the o1 object, right? So o2, that object that was there before that had that instance variable that was 3, now it's that whole object's gone. So that the variable is going to be gone as well. What object was it? It was o1, same as o1. When we created this one, we created it and it had self.b gets y, which is the default value of 3, but then later we changed o1.b to be 9, So currently o1.b should be 9, right? So when we say o2 gets o1, and then we print it out, that should be 9 as well, right? The first 3 is coming from before we do the assignment. And then we say o1.b gets 13. Yeah, well, o2.b is really referring to the same object as o1, so o2.b is also going to be 13. That's a run-through of preparation 6.py. It was designed to be confusing, just to make sure you understand the rules. My suggestions, if you are going to use private variables, learn a little bit more about them, practice with them. We're not going to be talking about them too much in the class, because we don't need them. Static variables, well, excuse me, class variables, we're not going to see too much of them, but they're basically the same thing as static variables in C++. So it just turns out in our applications we're not going to need them very much. If you did need them, though, just be sane and always refer to them with the name of the class. They belong to the class after all, right? Just to say, by the way, I said in class today that my class itself, what if I just type that? It turns out that my class itself, it's a little bit weird. It is an object. It's not an object of type my class, though. So let's see, what is the type of my class? It is a class object, right? So type of o1, that's an instance of my class. Instance of, is instance, right? Yeah. o1, my class. Yeah, but I don't think my class is an instance of my class. Yeah, right? So, but my class nonetheless is an object. It's of type class object. So that is where it's storing inside that class object. It's storing that class variable. So that's an interesting thing to kind of help complete the picture. But refer to, the point being, going back to whenever you have a class variable, just refer to it with the name of the class, dot the name of the variable. Don't do this little trick, even though you can. It's cute, but why do it? And whenever you have an instance variable, of course, you need to refer to it with the proper name of the object, or the reference to the object that you're trying to get the instance variable of.